Hey guys, welcome to DSC Mindset. Let's talk about another problem, that is search in rotated sorted array. Previously we have talked about binary search, right? And but if you're talking about rotated sorted array, let's try to understand what is the rotated sorted array, right? And then we'll try to relate with binary search, and you'll be able to understand more in details. So what is the rotated sorted array? First of all, you understand what is the sorted array. For an example, if we talk about minus 2, let me take, okay, so let's suppose if we talk about minus 2, right, minus 2, then minus 1 and 0, 5, 6. If you see that this is actually in ascending order, right, this is actually in ascending order, right? And in that case, we are good to apply binary search. If someone is asking that search 5, get me 5, get me the index for the 5, right? You'll be able to get it. You can just see that we can just index 0, 1, 2, 3, 4. So we'll be able to do that. So we can just set here low, we can set here high, right? And then we can find out the mid, and we'll see that if our target is higher or lower, right? It means higher or lower than mid, right? If it is actually higher, we'll shift basically low to right. So low will get changed equal to mid plus 1, right? Correct. And high will remain same. But if it is lower somewhere else, let's suppose I am searching for minus 1 or maybe minus 2, in that case we are going to say that high will get changed, low will remain same. So high will get changed in that case to mid minus 1, right? We have talked about this basically in the by another video which is on binary search. Maybe you can just have a look, but let me just quickly recap it, and then you'll be able to understand how it is happening. So here I do have code snippet for the binary search, how actually it does work. So we have low and high. We are just trying to check if low is less than or equal to high. Here we have low and high, right? Let me quickly highlight it. So we have low and we have high. High is nothing but nums dot length minus 1 and low is 0. So if it is meeting this condition, we are trying to calculate the mid value, and if it actually equal to target, then we are trying to return this mid. Else, if we are trying to check if our target is actually higher than mid, if it is higher than mid, means it is going to lie in the right side, means our high will remain same, but our low, which is in very starting, it will come to mid plus 1 because it's not lying there, right? And else, if it is target is actually lesser than nums of mid, basically we are talking about else block. In that case, high will become mid minus 1. If it is not found, it's mid minus 1 is going to return. That is all about binary search, right? But we are talking about rotated. So let's talk about rotated sorted array. Okay. So what is the rotated sorted array? Basically, if we'll see that rotated sorted array, right? So in example, the input is given as 4, 5, 6, 7, 0, 1, 2, right? We can see that this array is sorted, but it is actually rotated. It means we can just look at that 4, then 5, then 6, then 7, right? But after this part is sorted, and this part is also sorted, 0, 1, 2. Both are sorted, but it's actually rotated. If it is not rotated, then how it will looks like? It will look like 0, 1, 2, 4, 5, 6, 7. That will be the actual one. That will be ascending order. Like this is whole array sorted, and here we can just apply binary search and we can just search it, whatever we have discussed before. But this array is actually rotated, right? Okay. And for this example, if we talk about example number 1, right? Target is given as 0. So someone is like giving you the target, asking to search where is 0. So 0 to search it, right? 0, 1, 2, 3, 4, 5, 6, right? So here output is 4 because we are going to return this index for it because target is 0. Similarly, if we talk other example, it's a 3. Target is given 3. So where is 3? It is not there. And if you look at that in array, so in that case we are returning minus 1, right? And In this example, target is given 0, but in array only 1 is there. So we are just going to say it's not found, and not found scenario means it's -1, right? If you look at the another second example, once it's a 4, 5, 6, 7, 0, 1, 2. Input is same. Input is same as of example number 1 and example number 2 as well. But here target is 0, here target is 3. I hope you understand what is the rotated sorted array and how it is rotated, how it actually looks like. Let's try to understand how we are actually going to solve it. See, what we have seen that in case if it is completely sorted and it's not rotated, so we know that if mid is found, right, if the value at mid is actually found, we are going to actually return it. But if it is not found, right, maybe target is greater, then we are going to move to right side, and if it is lower, then we are moving to left side. Means we are trying to say high is mid -1 because it's completely sorted. So array will be given for this condition will be, let's say 1, 2, 3, 4, 5, 6, something like that. And yeah, it's easy, and we know that where it is going to lie, because if it is found at mid 3, let's suppose I'm searching for 5, then we'll return it. If it is not, we will check that whether target is higher or lower. If target is higher, we'll simply, like, let's suppose low was here, high was here. So what we'll do, low will come here. Like this is mid, let's suppose this is mid, right? So what we are trying to do that, we are trying to say that mid +1. So now I'll move my low pointer to low will come here. It will come like mid +1. We'll try to look at in this particular part, second part, because it's completely sorted. Now it's rotated. What we'll do in that case? It's very interesting and very famous problem. So let's look at that, what we are doing that. Let's try to first understand it, this particular problem. We'll take an example and we'll do dry run to understand more in details. Right? So let's look at that. Same thing. Here also we are taking low equal to 0, high equal to nums dot length -1. We are saying that if low is less than or equal to high, we are calculating mid. And once mid is calculated, we are trying to look at that. Whatever the element is there at mid equal to target, we are returning it. If not, here is a trick. It's a very important problem, just to say again. What we are trying to do, if it is, we know that it's not sorted. So can we say that one thing, if it is actually not sorted, so can we say that, let's suppose in this example, 4, 5, 6, let me take this, particular input, and we'll try to understand that. Let's suppose if I'm talking about 4, 5, 6, 7, 0, 1, 2. Let's suppose if I'm trying to say here we are actually having low, right? This is the low, and this is actually high, right? And here I'll say that mid will be something like, so let's index it also, 0, 1, 2, 3, 4, 5, 6, right? So if we'll try to find out the mid, so mid will remain, mid will be something like low plus high by 2. It's like 0 plus 6 by 2. We can say it's a 3, right? That is 3 right now. So if we're taking 3 here, 3 means third index. So like we are talking about here we are talking about mid. So that will be for sure that either first part will be sorted or second part will be sorted. If you look at that, this particular part, right, what we have done, mid. And if you look at that, this is first part, and this we are saying that second part. This is second part, right? So if you look at that from here to here, this portion, so we can see that the first part is nothing but a sorted, this particular portion, right? It's sorted, 4, 5, 6, 7. This is also sorted. Unfortunately, our mid is coming exactly like a kind of at the pivot index. But let's suppose if I'm considering, right, mid is somewhere else here, then also we can say 4, 5, 6 is sorted, right? But if you're considering the second part, 7, 0, 1, 2, that is actually not sorted. It's not fully sorted, right? So one of the part definitely will be fully sorted, right? So what the logic we are going to actually apply it here? What is the logic we are going to actually apply it here? So in that case, we are saying that if nums at low is less than or equal to nums at mid. Means kind of we are saying that 4 is less than 7, right? If first part will be sorted here in that case, right, we'll be able to see that 4 is less than nothing but 4 will be less than 7, right? That we can say that. But if you're taking that second part, right, let's suppose second part we are taking something like mid is coming here at index number 2, so we'll or maybe mid is coming at index number 2, right? So we'll say that 7 is less than 2. That is actually not sorted. So means what I'm trying to say, that this is a low index, this is something like high index, then in that case we are trying to say it's a sorted, right? So the example which I'm trying to take, let's take only one case. I'm just considering mid is equal to this index number 3, as we have calculated here right now, right? So we are able to see that first part is sorted. If first part is actually sorted, what we are actually trying to do, we are saying that if it is sorted, let's check our target is there in that particular part or not. So how we can check that? We can say that nums at low is less than or equal to target, right? Target will be either equal to low or it will be greater, or target could be lesser than mid. We are not saying here equal condition if you look at that, right? Because equal is already getting handled in this particular portion, this portion, right? So in that case, what we are trying to do, if I'm saying that whatever portion is sorted and that portion we are taking that, and in that portion our target is lying, so in that case we are good to say that ki high is nothing but high is a mid minus 1, right? Because that's sorted and that's lying. So low will remain same. Low we are not changing. High it was at last index initially. It will come to before mid minus mid, right? Before mid just it's like mid minus 1. So what we are trying to say here in that first part, considering first part is sorted, right? And we are right, since there are chance of getting okay. One thing I just want to tell that considering the first part is sorted and we are putting equal condition in the first part itself, right? That is a different story. Why are putting equal condition in first part? Reason being, we'll take another scenario and then we'll understand that. First part itself is since what we are trying to do, since there is a chance of getting high is negative, which is actually not good, right? We can just take another example just to do dry run. For an example, that dry run I have just noted down, like if we'll take a 3 and 1 as an input and we are searching for a target equal to 1, right? In that scenario, if this is actually not equal, this portion, right, this portion, then it's a problem, right? If we're just relying on the else part, then it's a problem. I mean, this is very tricky, but yes, we'll talk about this particular test case later on, but we are currently focusing on this part. So let's come back on what we are discussing right now, right? Let's come back. So what we are saying here, that we are saying that if it is real lying in that, then in that case we are saying it's a high equal to mid minus 1. If it is not lying, then it is actually second part, then low equal to, we are saying that mid minus 1, right? This if condition was we are considering sorted. If it is not, then obviously we are considering that else part is sorted. If first part is not sorted, then else part is sorted. That is we are considering by default, right? So in that case we are also checking the same thing, whether target is lying between mid and high or not. That is what we are checking. If it is lying, then I am saying low will be mid plus 1, else high will be mid minus 1, right? And if it is not, then we are saying that minus 1. It's a not found scenario. That is overall things. I will do dry run. We'll do dry run and we'll try to make you understand like how the things is actually happening, and then we go with the code. Let's try to clean it out very quick what we have discussed here, and then we'll take the example and to make you actually understand that how actually things is working. All right, let me take the example. Same input. I'm saying that the input is nothing but 4 5 6 7 0 1 2, and here target is what? Target is nothing but 0, right? If target is 0, then output will be 4, right? How? Because here 0, 1, 2, 3, 4, 5, 6. So if target is 0, then obviously we can see that here that we are going to return this part, right? So let's do dry run very quick. What we are doing? We are saying that low is 0, high equal to nums dot length minus 1. So low will actually be 0, and in that case high will be okay, we are saying that high will be 7, right? I mean length minus 1, so 7 minus 1, which is nothing but 6. So we'll calculate mid will become 0 plus 6 by 2, it will become 3. We are now here, we are trying to search it, we are here, right? We are trying to search it. What we are trying to search it, whether target is actually equal to this portion, right? Target is actually equal to whatever we have, 7 is equal to target, which is nothing but 0, is it? No, it's not. If it is not, we're trying to say that nums at low is less than or equal to nums at mid. Nums at low is nothing but 4, and nums at mid is what? Mid is what? Actually nothing but 7, right? Whether this is condition correct? Yes, this condition is correct. So first part is actually correct. We'll come here, we'll try to check that whether target is also lying. So we'll see that if low is less than or equal to target, means I'm saying that 4 is less than or equal to 0, and target means 0. Target is 0, right? Is less than nums at mid. Nums at mid, what is the currently? It's nothing but 7. So I can see that this condition is not correct. This condition is correct. So obviously overall result is false. So in that case low will get updated. So if you see that this line, right, low is mid plus 1. So low will become mid plus 1 is nothing but 4. Mid is currently 3. So it will become mid plus 1 is nothing but 4. So I'm just saying that this will become now 4. Now we are just going to search between 4. I mean mid is 4. So we are kind of having remaining part, which is nothing but 0, 1, 2, right? And index from 4, 5, 6. That is what we are having. Now again we'll try to calculate the mid. So if we'll say that mid, so mid will become low plus high by 2. It's like 4 plus 6 by 2. It's like 5, right? So now we are trying to search it for 5. We are saying that whether its target is equal to 0 is equal to 5. No, if it not. If it is not, then we are trying to what? We are trying, this is mid, right? What you are trying to check? Whether nums at, let's come back here. We are trying to check that if nums at low is what? 4, right? Is less than or equal to nums at mid, right? Nums at mid, we are here actually, right? Nums at mid is what? Nums at 5. Nums at 5, what is the value at nums at 5? Is 1. This condition is not lying, right? So we are saying that nums at low, nums at basically 4 is nothing but nums at 4 is nothing but 0, right? This is the one. Okay. Yeah, nums at low, nums at basically 4, this is low, and if you look at that, nums at 4 is nothing but 0. So I'm saying whether 0, this part, right? 0 is less than or equal to nums at mid. Is it? Nums at mid is there or not? What is the value at mid? So see that the value of mid, current mid is nothing but 5. So value at 5, right? Which is nothing but this one. I'm taking this. Yes, this is correct. Then I'll go to the if block, means I'm just going to cover this part. So I'll say that again nums at low, which is nothing but 0, is less than or equal to target. Target means what? 0. Is it? Yes. And target, which is nothing but 0, right, is less than nums at mid. So what is the nums at value at nums at mid is nothing but 1, right? We can say that mid value is 5, and if you see that at 5th index we have value here 1. So that both the condition is getting lied. So in that case I'm saying that high will get updated. So high will become what? High is mid minus 1. What is the value of mid? Mid as 5, right? So 5 minus 1, which is nothing but 4. So high is going to be updated now 4. So now we have low 3. Low is 4, and this is also 4, right? This is also 4. So we are just trying to check that again. So 4 plus 4 by 2 is made. Now it will become 8 by 2, which is nothing but 4. So now we are going to check that whatever we have at index 4, right? Index 4, what do we have? Index 4 we have 0, right? Whether whatever value we have at index 4, like, right, is equal to target or not. Yes, it is. So 0 is equal to 0, right? Then we are going to return it. So what we are going to return? Return the index. Index is what? 4. So 4 is output here. 4 is the answer here. That is what we are going to return it, and we are going to solve this problem in order of log n, right? If you look at that here, so let's start it. So basically, if you see that this is integer sorted in ascending order, but actually it's rotated, right? And here it is. You must write an algorithm with order of log n function runtime complexity, and that's the input. That is what is given, and order of log n complexity we are able to kind of solve it. If we'll try to go to the coding part here, so let's try to understand that this is a code. We are doing the same thing. We are taking low, we are taking high. We are saying that low is less than or equal to high. We are trying to calculate the mid, and if we are saying that if whatever value we have it at mid is equal to target, then we are saying it's something like this one, right? We are trying to say that return it, and I have also written a comment just for understanding, considering first part is sorted. And yes, if it is sorted, then obviously it will be, how can I make sure that it is sorted or not? In that case, I'll say that nums at low will be less than or equal to nums at mid, right? If it is sorted, then this is going to be true. If it is not, then else is going to be true, right? And we're checking that if it is, and also we are verifying whether target is lying. If it is, then we are just going to move that high. If it is not lying, then we are going to move to low to mid plus 1, right? Similarly, in else part also we are checking in else part. If it is, then obviously it will be between mid and high, and first part was between low and mid, right? In first condition true, right? So that is what we are doing. Okay, I think something happened wrong. Let me reset it. Yeah, so now this is some basically we are going to move the pointer based on that, and then we are finally saying that if it is not found, then it's -1, right? Okay, so that's overall solution, and I have also showed you how we are doing dry run, right? So I'll just try to run it. If we just try to run it, we can see that all the test case is getting passed, right? And we are saying target is 0. In that case, we are returning 0. In test case number 2, what we are saying, if target is nothing but given 3, so we are going to return -1 since it is not there. And test case number 3, right, target is given 0, but in this array is not found, so we are saying -1. Now I'll submit it. Is accepted, right? If you look at that, run time is taking very less, right? Is taking 0 millisecond, right? So here time complexity is order of log n, which we are able to solve using binary search. Whenever the problem statement says you must write an algorithm with order of log n, then definitely like the way is to use the binary search, right? So we are able to kind of solve the problem in order of log n. Let me know if you have any question in the comment section. Thank you for watching.